what's the main problem? What was the main problem? Or what is the main problem here?
Angle.
I've already told you how to do it, so I'm just saying it in past tense. The angles. The problem is a little bit with the angles. It's not a problem, but we have no idea what 285 is, right? We have no idea what's 45. But you can simplify it. We can simplify it using the property of something called as, something that you know, sine 90 times something plus theta equals to, you can write it as either sine theta or cos theta or minus plus something like that, right?
Yes.
You can decrease the value, isn't it? You can decrease the value. So, LHS cos 285 can be written as
360 minus 7.
270.
no, let's do it
270 plus 15 degrees.
plus
Cos 360 degrees minus 15 degrees.
Isn't that interesting?
Yes.
Because you know what happens when there is 270 plus theta, or you know what happens when it's 360 upon plus or minus theta, right? So you got sine 360 plus minus sine 360 plus. Looks like all of them are going to be reduced into angles of 15 degrees, right? And that makes our calculation much easy. Really easy, right? So, cos 270. So we know this. So this is 90, this is 180, this is 270.
This is
So,
660.
here all positive, here
Yes.
sine and
Cosec.
here
Tan
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 and
and
cot.
here
Cosec.
cosine. So, where does this 270? This is odd multiple. So whenever you have odd multiple, it changes.
Changes.
Cos changes into
Sine.
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 Of course, 15 degrees, right? The whole thing goes up. 15 degrees. Whether it's is it positive or negative?
Negative.
270 plus theta.
Negative.
Negative. It's negative. And similarly, plus. Cos 360 minus 360.
60.
360 is even multiple, so it does not change.
Cos 15.
Cos
15.
is it positive or negative?
Positive.
So here 360 minus fourth quadrant, cos is positive. So here sine 360 plus sine, that means it's even multiple. So
It doesn't change.
It doesn't change.
does not change.
It remains positive. Sin 75 degrees.
Is it positive or negative?
Positive.
Positive because fourth quadrant plus something, the first quadrant sine is positive. Minus sine 360 plus 15. So first quadrant
Minus sin
does not
Sine 15.
positive.
sine.
15.
All of them are in 15 degrees, right? You have 15 degrees except here. But this one also can be changed into 15 because 75 is 90 minus 15. So let's do that as well. Sine 15 plus cos 15 divided by sine 90 minus 15 minus sine 15 equals to minus sine 15 degrees plus cos 15 degrees divided by this one changes, right? Cos 15 degrees. Positive or negative?
Positive.
Positive. And then here you have what?
Minus.
Minus
Sine 15.
sine 15 degrees. Here cos 270 plus 15, that is in the fourth quadrant, cos is positive. Why did we write minus here? Why did we write minus here? Nobody told me. Is it not? Okay, na mane?
Yes.
Money. And then, now,
Multiply.
So the thing is, what we can do is, we have no formula sin C plus cos D or something like that. But what we can do is, if we multiply the denominator by cos 15 plus sin 15, it goes into the formula of cos square 15 minus sin square 15. What happens? Cos square 15 minus sin square 15. Cos square minus sin square can be written as cos 2 times 15, so which is cos 30 degrees. So we know the value of cos 30 degrees, right?
Yes.
So therefore, what do? We multiply here. Multiply here like this. We multiply by cos 15 plus sin 15
Also
divide by
cos 15 sin 15.
cos 15 plus
Sin 15.
sin 15 degrees. Cos A minus B, A plus B. What is it?
Cos square A minus
Cos square A minus
Sin square.
sin square. And A plus B times A plus B. What is it? A square plus 2 times A B, right? If you multiply, you will know.
plus cos square 15
Sin square plus cos square 1
1
plus 2 sin A cos B is
cos
sin
2a
2A, 2 times 15. Divide cos square and sin square
cos
Cos
2a
square.
equals 1 plus sin 30 degree cos 30 degree equals 1 plus sin 30 is
1/2
cos 30 is
root 3/2
1 plus half is equals 3 divided by 2 times 2 divided by root 3. 2 cancels off, gives us 1. 3 is what?
Root 3 into root 3.
root 3 cancel 2
2. Alright?
yes
So that's how you can solve the problem. Problem. No. That's it. Okay. So that's a beautiful problem actually. Looks simple, but you need to use certain techniques here, and here. This is the main point here. That's the main point, okay?